All right, guys, we're going to talk about quadratic functions. It's an introduction. Some of this will be review because we've seen it before for other reasons. For example, standard form of all quadratics. The standard form is of this form, ax squared plus bx plus c. And we saw this when we were factoring, but I wanted to talk a little bit more about it and make sure that we see that there are different forms of this quadratic. Keep in mind that it's quadratic mainly because it's raised to the second power, right? Whenever you see the highest degree is 2, it's a quadratic function. Right? If you were to look at the actual shape of this thing, all quadratics have a U shape. And that U shape is going up when this thing is positive. Now, if I were to do one where the A was negative, so everything else the same, let's just say, then what that negative does is that it makes it go downwards. That's all. So it's really based on the A, whether it's upwards or downwards. All right. Let me just do a quick little example and point out a couple of major things about some. So let's just say I give you a function, a graph of a function. And let's just say that at 2 and at -2, and then here, and then here, and then here. Let's just say that's our function. Let's say that this was at, 3. All right. So recognize that first off, my A must be positive. There are a couple of things on here I want to point out, though. So you see how the absolute bottom point, this thing right here, it's a point, and from there, everything is higher than that. That thing right there is called a vertex. It's just the highest point or the lowest point. In this case, it's the lowest point of this graph. This graph is called a parabola, by the way. Parabola. The vertex is, in this case, the lowest point of the parabola. From functions from before, in other words, I'm saying that in this case, it is a minimum. All right, a couple other things. If I were to draw a line, a vertical line through this vertex, so I'm going to assume it's right here, this line right here. That thing right there has a name. It's called an axis of symmetry. So this thing, this line, this vertical line that goes through the vertex is the axis of symmetry. And since it's a vertical line, that means that the equation of that line will be x equals something. Now in this case, the x value is 0 because it's going through the origin. So in this case, it's x equals 0. But that's the axis of symmetry. And why is that important? Because if it's the axis of symmetry, symmetry means it's the same on one side as it is on the other. So if I go 2 units this way from my vertex, I end up with a point right here, an f of x, or a function value of 3. Because it's symmetric, if I go 2 units this way, I should also have that same value of x. So it's symmetric here. This amount and this amount are the same, and you see that they end up at that 3. All right, so not only do I know that the parabola will go up forever in this case and has a vertex down here, which is a minimum, it has an axis of symmetry that goes through that vertex. All right, I could similarly show you one that looks a little bit different, maybe the opposite version of that. And let's just say that I have at 3, and then at, say, 6, and this is at 0, I have one at 2. So say there's my vertex right there, and let's just say it's going down instead. Right? So I know that in this case, my A is negative because it's going down. But let me point out those same items. This thing right here is still called the vertex, but in this case, it's the maximum. It's the highest point. If I go from 3 to 6, or from 3 back to 0, because this is 0, I'm still only going 3 units in both cases, and you'll see that I have the same y value. It's 0 in both cases. My axis of symmetry is the line that's going through the vertex, which is right here. It's a vertical line. It's when x is equal to 3. So just looking at the basics of quadratics, I could get bits and pieces from it. Axis of symmetry, vertex. All right, we'll move on after this.